Okay, it's time for some VSCP videos shots here again, and this is the refrigerator setup once again. And what we have here is a bridging board. This is connected to a relay on the fridge, and we simulate that relay here with the LED. This relay goes on when the temperature is too high in the fridge, and off when it's reached the set point. And to sense the temperature, we have this Kelvin and TK10 module, and the sensor is here. It's a thermistor. So in this setup we have set up things like this. I want to show that. It's a socket CAN interface for this local setup. So what we want here is to really have a system that is autonomous, of course, and I know now that this is the first module, so I get the configuration for it. And the zone for this module is 23 hex, and we have subzones for each temperature sensor in it. We have the onboard temperature sensor here, which outputs its temperature in Celsius, degrees Celsius, and we have the second temperature sensor, the first external temperature sensor here, which outputs its temperature in degrees Celsius also. As we see here, is B9 as the configuration, and this sensor also have the low alarm enabled and the high alarm enabled, and it also sends continuous alarms, and instead of alarm event it sends turn off, turn on events. Here we can read the values for the sensor, or the report intervals for the sensors. We have a longer interval for the onboard sensor, and 10 seconds for the sensor in that is supposed to be in the fridge. There's will be two sensors in the fridge. This is the first one, which no, not in the fridge, in the refrigerator, and the first one is in the refrigerator, and the second one is in the cooler, which should be a bit hotter. The B constant for the thermistor, and here we have the low alarm set point, and for we don't want it for the sensor 0, so it's not set, but here we have it for sensor 1, and in this case the low temperature is set to 27 degrees Celsius, which is a little strange for a fridge, but for this setup it's set here for demo purposes. And then we have the high set point, and the same for sensor 0, but we have this one here, which is set to 29 degrees Celsius, which is the same here for just for the demo. And then also important, we have the zones set up here. So the zone is 23 for hexadecimal, 23 for zone for sensor 1, and the subzone is 1 for sensor 1. And the last thing here is in this setting we have the absolute mean and max here, for example. But the last thing we have here is the hysteresis for the sensor, and that's 2 in this case. That's the standard value we use. So this is the Kelvin NTK NTC 10K module, and we go to the Beijing module and look what the settings is for it. And again, I should go up here. The zone is 23 hexadecimal, and for IO0, this is the IO where the relay is connected, and in this case the LED is connected. The subzone is 1, and we have a LED on the final setup. We have a LED on IO1 also, so it has the same subzone. The IO direction here is an output for the IO channel 0, and we have status registers here, and this is the output control for output control 0. And what we see here is that the output is enabled, and that we should send an off event when the output goes to its inactive state, and we will send an on event when it goes to its active state. We see that soon. And this is for the rest of the sensors. And we have input control registers here, but we don't have any inputs. In this case, input stream samples, pulse time if we want that, protection timer settings, etc. But the decision matrix is important in this case, and we can look at that here if we want also, but I want to check it in the registers instead. And what we have here, the first row is the decision matrix doesn't check the originating address of the event. It's instead check the zone and the subzone. This is set here. It's a zone, subzone, and then we have the bits for the class mask and the filter, and then the row is enabled. The class mask is all ones, and the event class we want to match on is 1E, which is the control event class, and the type mask is all ones, and the event we want to trigger on is turn on in this case. And the action we use if this event comes from or for a zone, subzone that is set for this, will turn on output 0. So it will turn on output 0. And in the same way we have here a decision matrix row that will turn off the IO if a turn off event is received. And that's it. We can see this here also. If we look at it, enable row, zone should match, subzone should match, and the class mask is all ones, and the class filter is 30, which is class 1 control, and we have a type mask which is all ones, and we have the turn on event, and the action is set output of IO channel high, and the IO channel set is 0, and the other row here is it's the same, except that the type filter is turn off instead, and this is also same but we turn the row off, turn the output off instead. So what we have set up here now is something that a setup that will have the LED on the board here will be turned off as long as the temperature is under 27 degrees, and which will turn on when we go over 29 degrees. So let's look at it, how it looks. And for that we open a client window. Again, it's a socket can here, and see what we have. We see the turn offs events coming in here, a lot of them, and that's because we set them continuous, and they will come here every second. And if we look at the temperature coming in from sensor 1, as we see here, it's 25 degrees now, and it reached the set point, and the relay should be off. You can see the temperature again here in a few. And look at the turn off events. We see that it's zone 23 and subzone 1, and it's a turn off. And that's correct, of course, the sensor is off. But if I hold this temperature sensor now, the temperature should go up above 29 degrees, and that happens here like that. And now I release it, and if we look at the logging here, we see that we now get a turn on event. The compressor of the fridge should be working, and if we look at the temperature, we see that it's 28.18 degrees at the moment, and it's still turn on. Now we have the hysteresis that from 29 to 27 degrees the hysteresis is active, so the turn on will continue until 27. So we will see it for a while more, and we still have 27 degrees, and we can see that it's gone off now. Yeah, we went below it. I got a little confused here, but I can do that once again to see it. We are on 25 degrees here, so I went a little fast here. So I'll hold it again here. Do a little faster this time. We go up above 29 degrees. There it is. And we wait again and see how long it takes. There we see it. It's 28 here. 27. Well, it's cold here today, I think. You see it's still on. And there the turn off came, and it's off. they are a little bit close here, but I don't want you to wait too long. So the only thing I need to do now to get this fridge working is to change the temperature. The low alarms will be at 2 degrees Celsius, and the high alarm will be at something like 5 degrees Celsius or 6 degrees Celsius. So, and then connect them to the relay. So that's all that is needed. It is working now. The nice thing with every VSCP system is that they are really self-contained systems. So this will work without any server doing anything, and it will just work as it is. So we just can mount it, but we can also control it with a server, of course, and we can monitor temperatures and have alarms if they go out of range. Okay, that's it. Thanks.